Hi, I'm Cheryl Leach. The problem we're going to be working on today has to do with marginal analysis. And in particular, we're going to be looking at a cost function and seeing how that cost changes when the production units increase by 1. Yes, thank you. Should I start just with...
Yeah, just whenever you feel comfortable.
Okay. The problem we're going to be looking at today has to do with marginal analysis. We're going to be looking at how the cost changes when our production level increases by a single unit. So we're going to be going from 12 units produced to 13. Now there are a couple of different ways we can look at this. One way is to use an approximation using differentials. Another way is to actually calculate the change. In either case, we want to pay attention to how x is changing. If we're looking at the actual change, we'll be talking about delta x. And when we use differentials, we'll be using dx. And in both cases, that change will be 1. So let's go ahead and start with our approximation. So we'll calculate the differential dc. Now we know how to do this. We first find the derivative, dc dx, and multiply by dx. So we need to calculate the derivative. So this is a constant multiple times x squared. So I have 0.05 times 2x plus the derivative of 4x, which is just 4, times the derivative of 10, which is 0. And then we're going to multiply the whole thing by dx. A little simplification gives us 0.1x plus 4 times dx. Now we can enter the specific information for this problem. In this case, my production level is at 12, and my dx, which is the change in the production level, is 1. So I have 0.1 times 12 plus 4 times 1, which is going to give me 1.2 plus 4, or 5.2. And again, let's think of units. This is the change in cost, so this will be measured in dollars. So this is approximately how the cost will change when I increase production levels by 1 unit. Well, let's go ahead and find what the actual change in cost will be. So that involves delta C. So what I want to do is find out what is the cost when 13 units are produced, that's C of 13, and subtract what happens when I produce 12 units. In both cases, it's a function evaluation problem. I need to plug 13 into my cost function. So I'll have 0.05 times 13 squared plus 4 times 13 plus 10. Then I'm going to subtract what happens when I plug a 12 in. That'll be 0.05 times 12 squared plus 4 times 12 plus 10. I think at this point I'm going to pull out my calculator to help me get these answers. So I'm going to have 13 squared times 0.05 plus 4 times 13 plus 10. That's going to give me 70.45. I then am going to subtract 12 squared times 0.05 plus 4 times 12 plus 10. And that gives me 65.2. When I subtract these two numbers, I end up with 5.25. And again, the units are in dollars. So I have the exact answer of $5.25 and the approximate answer of $5.20. Now, it wasn't too bad to calculate that exact answer, so why would I want to use my approximation? Well, what happened if I changed this production level and I wanted to go, say, from 20 to 21 units? I would have to find C of 21 minus C of 20. And again, a lot of number crunching to get my answer, but it would work. On the other hand, if I use my differential everything is the same right until this point. And I could plug in my 20 and 1 in this location, and there's much less number crunching to do. So it's a little easier to calculate using the differential. Another advantage is that I have a function that I can analyze. So we have the exact answer and the approximate answer that has some advantages to it. I hope this is helpful. Thanks.